Check. Okay. Hello everyone. Here we are again for with the next episode in the series to develop the Pixel Painter challenge game. Last time we did a lot of effort. We were looking into the algorithm to detect whether lines were crossing. And then we came up with we found or at least I found an algorithm online that didn't really quite work. Turns out the algorithm was actually quite okay. So it worked, but it was just missing certain cases. In that sense, that currently in here you will see the very similar algorithm, which relies on the calculation of the difference in y times the difference in x and whatever between 3 points, start, middle, and end, which technically they should be thingy, but where the previous algorithm just checked whether it was counterclockwise, I think it was, and then it did some stuff with it. Now I have an algorithm that actually doesn't just check counterclockwise, but also checks clockwise and collinearity. Collinearity? Collinear. To see whether the points are collinear, so it means a straight line. Why is that important? Because, well, if I go from one point to the thingy and back, those two lines, if I go from here to here and back, well, then technically that's collinear. Why again did you need the Yeah, it's because you compare the one line with a point and then another. It's a very interesting algorithm actually. So how does it mean? It's not fully implemented yet in that sense that the collinearity is not completely working. So if you see this one worked, um, and then now here it will say like, well, actually we're crossing that. Why is that? Because, well, starting from this point, and well, this point, of course, is always crossing, but that makes sense because it should be ignored. Interestingly enough, this then apparently is not considered to be crossing. And why is that not considered to be crossing? And this one is also not considered to be crossing. Why is that? Because of the collinearity. Because if you see here, it will do a very weird comparison about, well, integer, so like the value, whether it's collinear clockwise or counterclockwise, and it will compare those two. So it will check whether O1, which means the existing line with the start, which in this case um, should be collinear, because yeah, they are crossing. That's the whole thing. I mean, you make triangles with it. That's how the algorithm works. So you make a triangle from here to here, and then between two other points, because these points are the same, so they're definitely collinear. So that would be 0. The other two, yeah, from line start, end, and line end, or the line end would be this point, then, well, that's definitely also 0. That's collinear. And so that's what I'm saying. Like, if O1 is different from O2, well, it's only not the case because they're collinear. So then I say, oh, they're crossing, so return true. And that's where the special cases comes in. Apparently, let's click on. Can I click on this? Yes, I can click on this. Okay, good. But I have to open it in the site section. So the thing, and the algorithm actually contains a lot more checks. So, but I think because of a bit of a special approach, I think I actually have to probably do something uh, myself, because I want to avoid certain sections. And that's what I still have to kind of figure out, is how to make sure that, this one, he points here, which, I mean, like, yes, it's saying like this point and this point, oh, they're collinear. Yes, they are collinear. Probably I don't even care about O1 because I know that well, I might care about, well, no, probably I don't even care about it, because the line start, I can never choose. You can't choose the start point of your line. It will always be the end point of the previous line. So why even check whether this is collinear with something? Because I know that this point, the end point, will always intersect with your previous line. That's just a fact. And it can never intersect with another line, because that would mean that you have made a previous line which is invalid. And also that means that it will actually be impossible to actually close your figure, because I would say like, well, that's the thingy. So I actually don't think I need the O1. I'm gonna comment it out just in case. And that's what you see here as well, what I've written. And like you see the numbers 1, 1, 0, 0, 0, minus 1, 0, 0, 0, 0, 0. And then I probably should remove the collapse because that makes it a bit difficult to see. Of course, now the code is not working. You know what? I'm going to keep the calculation. I'm just going to remove it from here. The question, of course, is, and that's so now it will allow everything. That's okay for a second. The question, of course, is because it's a comparison between O1 and O2. And of course, I can't have both of them collinear. I mean, that's the whole thing. Eh? It's like, oh yeah, if they're actually the same line, well, then, or if the line just continues, then it's considered to be not crossing, which is not true. I mean, that's not what I want. Again, so you have the line, and then here you will now see that it's like 1, 1, 0, 0, 1. Yeah, of course, this is not even a valid point, so it won't do anything here. You can also see like 1, 0, 0, 1. Y is O2. That's because the triangle, because my point here is on the same level as the point there. So that's why it will actually say 0 in the middle, because the triangle or the line, this one would perfectly form a triangle which could be connected with a straight line. If I would go on up, it actually stays 1, 0, 0, 1. Interesting. Okay, so maybe I don't fully understand the algorithm yet. But okay. And then if you go here, and then again, 1, 0, 0, 1. Basically, it becomes here becomes 0, 0, 0, 1. Why is that? Because your starting points start end. I think there is something wrong in my algorithm with regard to the points I do. Because how can it be my line start doesn't change, and yet my O1 does change? Nope, never mind, I got it wrong. Okay, so line start, line end is the comparison of the other start. Start and end is your existing point. So I also was even commenting out the wrong point. Okay, the wrong line. So the start and end here is your actual line. So this is the line I'm creating, start, end. That's also why the O1 will actually change and O2 will actually change. And O4 will change, but O3 should actually never change. You can see that this will be 1, 0, 0, 1, and if you go up, it will become 1, 0, 0, 0, 0, minus 1, 0, 0, minus 1. It will do a lot of different things, but the third digit will never change. As a matter of fact, the second digit also never really changes. What is the logic in there? How can the first digit also never change? The second digit probably also never changes because it's too dependent on line start, line end. I mean, the line start and line end in this case, because the line is fixed, will always be the case. So what will change? The only thing that will actually change between iterations is my end. That literally is the only thing. So curiously enough, why does the end, the second variable, why does that one not change? I think it might be because of the restriction I have on what kind of shapes you can actually make. Another interesting thing is that my points. Ah, yeah, no, that's okay. I was gonna say it's between. It doesn't check with the existing shapes, but that makes perfect sense, of course, because I have to be able to overwrite the existing or the current shapes. Otherwise, you can only color everything once, which is well the whole part of the game, I guess. So okay, so what do we have to look at? If we play around with it a bit, I have to. No, I can leave this on. I'll leave it. So what do we see? We see from here. to here. And if you then make another move, well, what do we see? It's 1, 0, 0, 1, and that's perfectly fine. So if I just tell 1, 0, 0, 1, and then we say that's allowed. If we go to here, we have again 1, 0, 0, 1, that's perfectly fine, that's allowed. In here, this is 0, 0, 0, 0. Well, that's actually an interesting part because that would mean that 0, 0, 0, 0 is also allowed. Then you have minus 1, minus 1, 0, 0, minus 1, I think it was. That's also allowed. That's up here. And then you have, yeah, minus 1, minus 1, minus 1. And then you come down here, and the problem is that this is also 0, 0, 0, 0, which then again becomes not allowed. So that's a bit interesting. Because you have this 0, 0, 0, which is allowed. And you have this 0, 0, 0, which So I'm not sure yet how to check for that. So it's a bit of a special case. And then of course you have the cases which I haven't checked yet, but like you have this case, of course, so you do like this, you do like this, and that's fine. If you do like this, and then this is all fine. 1, 1, 1, 1 is fine. Minus 1, 1, 1, 1 is fine. So when does it not become fine? Here, when I do this, which is, I don't even know which line it actually is I'm looking at. It is the minus 1, 1, 1, minus 1. So the minus 1, 1, 1, minus 1, that one is not allowed. And that's the interesting part. Everything else should be fine. But if I go here, then I will see this is a, so this is a minus 1, 1, 1, minus 1, 1, 1, and then it's either 0 or minus 1, I think it was. Minus 1 not allowed, 0 not allowed, 1 is allowed. So this is not allowed, which actually makes me wonder that this probably also is like, yeah, 0 minus 1 is not allowed. And that's the thingy, and then of course you have the horizontal one, which is minus 1, 0, 1. Minus 1, 0, 1, and then everything. So if I have minus 1, 0, 1, and then x, that's also not allowed, because that means you're actually on the same line, same horizontal line, I guess. Unless, of course, that this is not changing what I'm thinking is changing. The question also is like, am I now overlapping with this line, the horizontal line here, or is it now complaining about the horizontal line here? And that's also, of course, a thing that I don't know yet. So this, and then you have this. So, and then the algorithm says, okay, in this case, that was here the good old case, O0 different from O2 and O3 different from O4. Then it says, well, we're crossing. And that's considered to be the general case, which is true, it is crossing. And then you have special cases for collinearity, where a point lies on the same thingy. Lies on certain segments. Of course, in this case, we actually have points that are exactly the same. But I think what I probably can do is, I probably might have to, or what I probably have to do is I have to add a special case where I say, in case the point, if my start point is the same as my line end point, for instance, I probably have to do a special case. But we'll figure that out as we go. The only problem, of course, is that this will make it very difficult. Yeah? So like I'm probably going to do like if start equals line end. For now, I'm just gonna put it in there, and okay, I'm gonna be smart. Well, I will be smart later on. That's fine. I'll say return false. Continuation of shape. So this is technically not correct, but for now, it's an easy way to avoid me from not completing the shape. And then I can show you what exactly this general case fixes. So like, I mean, like, see this now, it will just say continuation of shape. It will completely ignore everything, and I can do whatever I want. So I can go here, I can go here, and then you will see that if I go there now, aha, it will say crossing 1. So it detects that this is crossing. This is, where am I? I am here. This is considered to be crossing. This is allowed, but this is crossing. So, and that's where actually the algorithm, like the perfect algorithm, just picks where it just works. Here as well, I mean, it handles almost all cases. Why? Because of course I took out the continuation check. So what does that mean? That currently I don't check for overlaps between the last section, which is this, and my current new line. So that's why this you can still do, which is funky because it doesn't check it. But everything else, it actually seems to handle perfectly. And why is that? Is that because the special cases, you have like P1, Q1, and P2 are collinear, and P2, now they've used P's. In this case, it would be like my line starts. My line starts lies on segment P1, Q1, and P1, Q1 would in this case be start end. So if you check with a line start, if I would perfectly overlap, which I can do actually, if I make the same shape, if I go from here to here and then to here, for instance, then this actually is being handled as well. Now, why is it saying that it's not? It says P1, Q1, and P2 are collinear. P1, P2. Ah, okay, I see, I see. So it has to be, you need to have two lines, start, end. My new line has to be in the same thingy as. So what I, for instance, could do, I could do here, and then I could do here, and then you'll see it. So this line, now if I do this, interesting. I think it's being handled by a different case. I should have gone to the back, I think. Okay, let's try again. If I take a line from here to here, I go down, and then I go to here. Okay, see, so this, for instance, is indeed a case that's not being covered, where you have your new line is actually like ends up overlapping with the other line, but from the bottom, from the starting point. So that's one of the special cases where they say like, well, look, you're actually, well, you're not the continuation of the shape, of course. That's because yeah, it's comparing with everything. That's really stupid. But you have the, what's it? Oh, 1 is 0. So you have the 0 and something else. Then this is problematic. Of course, I probably have to add an exact check as well to say like, well, if your endpoint is the same as your original endpoint, it should be allowed no matter what. But let's add this check in here now. So I'm gonna make it a bit more clearer for me to know what exactly which case does. So they say P2. P2 in my case is line start. Line start lies on segment. Yeah, so that's not. I have P1, Q1. That means the new line P2 line start. New line is collinear. It's a bit weird to think of collinear. I mean, because we're thinking in triangles. You have to think like this. You're thinking in triangles. This is collinear. So actually, I have to say start, end, line, start is collinear. So it means like my new line I was creating, so zoom line start, it didn't form a triangle. Why is that? Because I mean, like even if you go in different direction, then yeah, it's technically, I guess, not, or the algorithm doesn't say it's collinear, but it makes a weird triangle, I guess. Well, or maybe it handle that in a different case. That's what I'm saying before. So you have the thing. You're trying to make a triangle from your current line, but since these points overlap, you're not really making a triangle. It's not a triangle. It's like a simple line. So that's what I'm saying. They're collinear. You can't make a triangle out of it. Start end line start is collinear. And the new line goes, how do you say it, in the new line, and the new line continues into, or something like that. So, and then you get if 0 or 1 equals 0, and then they have this method saying on segment, and the on segment does some funky stuff. I don't think I actually copied that yet, so I will have to do that. Okay, so this method basically checks whether your given point lies on the segment. That's how they call it in mathematical terms, not a line, because a line basically has no start and end. Yeah, if you want to be mathematically correct. So then you have the point here. And then you have Q, which is end math.max of P plus S. Yeah, and R is your point. Q again is the E, P is the S, R is point. I mean, this is actually rather simple mathematics, but it seems more complex than it actually is. In this case, it was min math. I will rewrite this a bit because this is actually very weirdly written. So I mean, so this is actually basically a boolean. You don't have final bool, I guess. I think you have const bool. I'm not even sure if you can use const bool in this sense. X overlap X. So basically all we're doing here is checking that the endpoint. See, you can't do the expression in overlap X must be a constant, and it's not a constant. So that's C++, C sharp thingy with const, which differs from Java, which I'm more used to. So basically all you're doing here, you're checking here is whether your EX, so your endpoint of the segment you want to check, you have a segment from here to here. Now you're checking, is this point on there? So all you're checking is like, well, since you know they're collinear, then you're checking the line between your starting point and this point. Is the end point smaller than the maximum of the two, and it's bigger than the start of the two? And if you have your start point and the other point you're comparing to, and here you have your end point of your segment, well, then you know, well, it lies between the start point and your end point, so then it's fine. Another way to actually also do it, which you could check with your actual point. For instance, you could do, which maybe I'm probably going to do, is like point.x. If my point.x is smaller than or equal to math.max start.x and e.x, and point.x is larger than or equal to math min, this should technically be exactly the same. Why is that? Because you just have different comparisons, and then in one case, where in this case the max will be this one, and in this case the max will be the other one, and those kind of things. So you're just checking whether the point is smaller than the maximum in x, so that's in the x line, and it's bigger than the other thing. This only works if the points are actually collinear. Why is that? Because you're doing a straightforward check on the x-axis, and you're doing a straightforward check on the y-axis. So, I mean, if the points would not be collinear, then you can have, let me show it. It can't compile, so it won't do this. Damn, point.y. Okay, so apparently it will just ignore it if it can't compile. Interesting. So the thing is, if you have a line, and if I make a point here, then, well, it will be within x, because this is min, this is max, so it will be here. So it will be here, and it will be between x, it will also be between y. And so you might say, like, well, this point actually lies on the segment. Well, that's not true, because the 3 points are not collinear. I mean, that's why the thing is, this method only works if they're actually collinear, the points. So that's a very important thing to note. If I would move it here, then the points are collinear, and then I can just do a straightforward check to see, like, well, is my x, are you in x between, and are you on I between? Because here as well, if I have a collinear point that goes up to here, well, then you can check, well, the x is not between it, so you already fail. If I do a collinear point where the x is, so it's in this case, the collinear point there, you would be between on x, but you're not between them in y, so you don't overlap. But so this quick and simple math check only works for collinear points. That's a precondition, basically, to say it. Again, here also you really check the up until the end. So if you want to use this and you want to ignore so yeah, if I can just move this. Okay, formats. So back to our special condition. So the condition is that O1 O1 is the triangle between your start and end and the line start. So it means I'm making the new line and I check with line start, which, as I said, in this case, yeah, that would always be true, because no, it's not always true. Line end would always be true. So I do point, point, point. So I have this thingy, and then I have this. I have the new line, and then I take the beginning of the original line, then that triangle, if that's collinear, which we had in the one case where if I make a point like here and I have the new line and I overlap with this one, then it's collinear. I know that this line and this line are collinear. Why is it important to actually check whether it's on the segment? I think because it might also give false negatives. Compiler, okay, if on. So fixed compile error. So I mean, like, why, for instance, would it not be enough to just check any of these values, or a combination of these values? That I'm not really sure of, and that's how the triangle mechanism works. Can I cancel this? Okay, so that's closed. Okay, so I have the triangle here. So of course, it says continuation of shape. So this, all of this is fine, fine. But then if I go here, this also does it, but this is not being detected. Ah, yeah, that's the thing here. Like, this would not be detected. But now it does get detected because of a special case. And how come this is not being detected? That is probably because, well, you have all of these collinearity. The algorithm works with making triangles, and if the algorithm can't make triangles, then you have problems. It can perfectly detect triangles. For instance, this is a special case which I've removed. But so, I mean, the algorithm works perfectly with making triangles, but since this whole line is collinear, it can't really make triangles, which is actually very interesting that it actually can know that. So this triangle here, this is, we're still on the exact collinearity. Yeah, the new line and this line up to here is perfectly collinear. So it's interesting to note actually that in this case it was correctly able. Well, no, that's the thing. It can't detect it. Okay, it can't detect it, and because it can't detect it, because it's not a triangle, it just says, okay, it's allowed. So this, the algorithm actually would allow too much. That's a bit of a problem. And so the next case where it also fails is when Q2, which in my case is the line end, is problematic. So how do we do that? That's very similar, except then you go from here to here. I'm thinking whether this is the way to do it. No, this just seems to work. It's probably because I have to, yeah, I probably don't need this case for the simple reason that um, the second case would be if you have an existing line from here and you have a new line that starts from here and goes up to here. But I never have this case because you can never start from this point. Except, of course, yeah, where you have this point, where you have a line that goes up to there. But then again, we've seen that this actually is impossible because it always reports this as being wrong as well. So I don't think I need this case. P1, Q1, and Q2 are collinear, which again, P1, Q1, that's my new line, and then Q2 is my line end. Okay, and then the third one is P2, Q2, and P1 are collinear. So P1, P2, Q2, that is my existing line start, line end. And P1, which is start, they are collinear. So you have the existing line, and then with your given point, they are collinear. Again, so in what case would that be? That actually would be here the continuation of shape, which I think the algorithm also really already doesn't allow. So I think and that's where I think unit testing really comes in to see whether all of these cases are required. So you would have a shape. This is the P2Q2. And then you say basically something like this, and then, okay, well, this point is on it. So this is a triangle that is collinear. I think maybe this is not the case, or why this works. Well, not completely, because I mean, for instance, this is not allowed, this is allowed. Ah, yes, okay, so that's where you can actually see it. So where the algorithm actually fails. But in my case, that's okay. Where you say like, oh, this is not allowed because this detects that there is a triangle that fails. But in this case, because the whole line is collinear, it doesn't detect it. It doesn't detect it, and thus, yeah, fails. But actually, in my case, the third is definitely not needed. So it makes me think maybe I should look at the second case again. But I'm gonna take a quick break. I'll be back in like 5 minutes. Okay, so actually, I have a thought about the whole case with the collinearity. Um, and well, of course, yes, it makes perfect sense, and it's perfectly correct. The only thing is that what I failed to recognize was that the special cases are not just for lines that are collinear, but they actually have to be both lines that are collinear. So in this case, where I say start, end, line start are collinear, actually, this means that in this case, it means that the existing line and new line are not just collinear, but they are, how to say it, they are not overlapping either, because that's what you're detecting here, but they are Um, how would you say that? How do you say that two lines are lying in a single line? Ah, okay. Yes, the existing. Well, I should take the segment because it's the official mathematical name apparently. So cross of the lines probably also not correct. And new segment lie on the same line. How you lie on the same line. So the existing segment and the new segment lie on the same line. So it means like you have a line, single line, and both segments lay are on the same line. Ah, whatever. So existing segment and new segment are on the same line, and then you want to have to then you check for overlap. And this is where we are now. We are checking for overlap. And so in this case, we check for overlap. Check for overlap. Um, with line start, I guess. Because this is between the special cases, they have this check, the first check here, oh, 1 equals 0. And then it checks the point. And I think that's more to know which points to check instead of just checking all four of them. But you can also, so the second case would be very similar. But then it's 2, 0, and here you say line end. Then you have the exact same thing with 3, and 3 would be here line start, line end. Actually, this is a very interesting thing he does, because actually what he does, he checks P1, Q2. Q2 is line end. He also doesn't do start end line. Ah, okay, yeah. Okay, so what I did, I assumed you made the start, you take a line, and this is the point you want to check whether it's on the line from start and end. What he does is he doesn't do start, end, line, start, or at least in the article, what they don't do start, end, line, start. No, they do start, and then they take line start, and they check end. So I've changed this implementation here to see start, end, and then the point to see that should be on it. But what they've done, actually, they've put their point they want to check in the middle. So they check whether the endpoint is between the virtual line, whereas I've changed it. Okay, so that explains why their order is different. Also means I have to always swap those things. So start, end, line, end, yes. P2, Q2, yes, and then P1, yeah, okay, so I'm on the correct case. I'm doing it, this seems to make more sense to me. This should be start, not line start, and this has to be end. Special case 1, special case 2, special case 3, and 4. And then now we are on the level where we say, like, do we need all these cases? Well, and that's probably the point where we say no, because okay, we know this is the new line we are making, and here we have to check whether the line starts. Which was, if I make a point like make a line from here to here, I have to check is the line start on that line, which we definitely need to do. And this is the case where we say, like, well, is the line end on that line? So it means that would actually be the case where I would go from yeah, in the other, well, not in the other direction, because if you're in the other direction, then your direction is in the opposite thingy. But actually, that would be the case if you have a line from here to, if you would have this line, yeah, no, it's compiling again. You would have a line, and you would have another line. So means I would point from here to here. This, let's assume this line, and then I would do another line like this. But this, of course, would be then overlapping. So you have to shift the bits. mentally shift a bit. So this would be, for instance, the next vocabulary, because it's start, end. The problem is we can't have a line that says start, end, and start, end. That's impossible because you cannot start here. That's already an invalid position. The algorithm, of course, doesn't know that. So special case 2, we actually don't need. We don't have to check this case because it can never happen. Probably also means that's also why O2 is always 0, because you can't have this case. You can't have line end. You can't have the start end and line end become non-zero, because that would basically or no, you actually can have it. What am I saying? You can, it can be 0, because 0 means they are collinear. You should never ever ever have the case, I think, where they are 0. I think that's the whole point. Yes, you can never have it 0. That's why the case here I can remove it, because it can never be 0. Line end can, like O1, O2, can never be 0, because if it's 0, that would mean that your start and end would be on the same line as your line end of the point. Well, it would mean like you have like a straight line, and start, end on the same line. If you do the other direction, that's all different. If this would be start and this would be end, then again you're in a different situation. Weirdly enough. But so this, I think, should never become. This one, I think, my current understanding, O2 should never be 0. It's what I think. It's not 0, 2, but O2. O2 should never be 0. I think it's impossible because of directionality, because of the way you check it as well, with start, middle, end, and the calculation. Although, is that correct? If I say this is start, this is end, start, middle, I would make a triangle from start, end, line, end. So start, end, line, end, and then that's start, middle, and end. So I make a triangle, start, middle, end. That's basically what I'm trying to do. No, start, middle, end. That's what I'm doing. Start, middle, end. If I do from here to here and back, then how come the triangle does not become 0? They are collinear. They should become 0. I think O2 can become 0. I think what this thing is, if this becomes 0, well, then this should also become 0. It's a bit weird. I'm saying like this should never be able to have because of directionality, but I don't think the algorithm actually takes that much directionality into account. So, interesting. I will look into that later. So then here you have the line start, line end, and start. So this one we definitely don't need. I mean, that means that you have a start, the existing line start, line end, and you have the point where these two are overlapping, and now you want to check, well, is the start point of my new line overlapping with this part? How is that possible? Then you should not have been able to create a line like this. So this is impossible. Again, I think that's why we see for O3, we also have certain things that can never happen. I mean, yes, they can be collinear. I can make a point with start and I can make a line definitely that happens somewhere, but I don't think we actually have to check that case because we know that that case will never be any interesting point because you always start somewhere else. And then here you're checking line start whether the end point, whether the end point lies on it. And that's actually still an interesting point. Because it can be that you make a line and you have, actually I'm thinking, do you even have to check? Why do you have to check all 4 of them? If I have these 2 cases, line start, line end, line end, shouldn't that be enough to detect all overlapping? If I know that I have a line, a new line, and I know that the start does not fall between this point, and I have the end that does not fall between these 2 points, then how come I have to check whether these points are between these, that are the new points which are between there? I think actually this should be enough, these 2 cases. They might not be enough because of the check on O1 and O2, and that's maybe why we have to add them, but it definitely feels strange to me. So, okay, but now back to the actual thing. Do we need this actual check? Can we be smart about it? And can we, for instance, say, okay, yeah, this does not work anymore, of course, because I've deleted it. For instance, this is now allowed because why is this allowed? This is special case 1, that's we already implemented once. I think this probably could have been special case 2. I'm gonna just allow all of them again. I'm curious to. Yeah, well, I know special case 3 can never become true, but that's okay. So I think this actually should be all 4. And there's a bug in it. So again, we draw, and then here we see, indeed we see here that so special case 2 is possible. It's just because I had it disabled that it wasn't detecting it. Well, it disabled because I remove this part. So that's why the special case 2 is working. That's also why I think that actually the start end line start or start end line end is probably not an interesting case, but I could be wrong. I definitely have to do this. If start equals line end, continuation of shape, what do we still need to check? If I want to do a continuation of the shape, then I'm going to do this, so I know. So I can see which cases I actually want to do. That's temporarily. Because I can imagine if it's a continuation of the shape, well, then start end this O1 will always be 0. It's a fact. I mean, O1 will be 0. O1 is not 0. Start, end, line, start. No, makes sense. It's O2 that's always 0. You can see O2 is always 0. And in here everything is 0. Okay. So we know, I mean, like this O2 is always 0. It has to be always 0 because, yeah, your start, the new line you're making and the line end, yeah, they overlap. So no matter how you try to make a triangle, since this point is the same, start, end, you have your start, you have your end, and then, yeah, your end point, start, end, line, end, will always be on the same line. You cannot make any line where this point is outside of the line. So that's impossible. So that's also why the second case here is not interesting. Special case 2 is not interesting in this case. Probably a lot of other cases are also not interesting because, for instance, line start, line end, and start, O3. I think O3 is also always 0. Why? Because, yeah, you have your existing line, line start, line end. Yeah, and your current start point will always be, because you're not moving it, will always be on the same line. So it'll also be always O0. So just you have to remember that there actually was one here. You see it's always 0, 0, 0 in the middle, and then you only have the end points. So what do we still have? Well, we can, I guess, have this point, but that is not going to be very interesting. Is that very interesting? Because I think in this case, see, in this case, for instance, you have 0, 0, 0, 0, but this should be allowed. That's a whole special thing. This should not be allowed, but this should be allowed. And that's where the directionality actually kind of comes into play, which is a bit annoying. So I can't just do this check. I think, because I think what I have to say is like everything is allowed as long as it's not 0, 0, 0, 0, 0. I continue of check if line goes back on previous line. If segment. So I mean, like, I know that if I start from this line and no matter what direction I go, it's always fine for this one, except if I go back on this one. And if I go back on this one, how can I know that? Well, it's very simple. I just check whether no, because I can also go outside of it. I think I have to check if O1 is 0. This is not 100% correct. Because now it also does this case wrongly. So basically what I want to check is I want to see whether this point is going backwards on this point. That's a bit annoying. How am I going to check that? How am I going to check that? Because this is fine, this is not fine. I actually have to see that. Since I know my start is the same as my line end, I probably have to do a direction check. Is return, yeah, well, not is same direction, because or well, I can do is inverse direction or something. How can I do inverse direction? How what do you mean direction? How do you do direction? Is this what you have direction in X and you have direction in Y? How do you check that? I was gonna say get direction, but private boolean is inverse direction, and vector 3 int s vector 3 int e vector 3 int ls and le. Actually, it doesn't even matter, because I mean, like, I know start and line end are the same. I can probably do it better. I can do it smarter. So I know start and line end are the same. So what do I have to check? I just have to compare then end and line start. I think I have to take the difference or something. If I say end.x minus start.x, and then I have to do math of the sign. So this basically gives me the directionality of end and start x. And that's only here in this case. If O is 0, actually I can do it differently. If O1 if O1 is not equal to 0, then it's always false. Other cases, I have to check direction of line of segments. I'm not sure if that sequence really have int x direction, and I do int y direction equals math.sign end dot y minus end dot start dot y. And this again is like the directionality of your point. If I do for instance here, then I see like okay, I go from a high x to a low x, and I go from a high y to a low y. So this will be both positive. This will be x will be positive, y would be negative, and here you have the x negative, but y positive, and here it's both negative. So that's important. And then I say int x line direction, or line x direction. I really have to work on my names. I have to come up with better names. That's for the same. Yeah. Int line y direction. Okay, it's the same. And so when do they actually cross? They cross if x direction is line x direction and y direction equals line y direction. In this case, actually, it's not a problem because I know like the direction from this point to this point is the same as this point to this point, so they're basically just a continuation of each other. It is only if they are not on the same line. So I say this is different from, or this is different from. So then in that case they do, then I say I just return this. Is he gonna add braces for me? He does not. If I add them myself, is he gonna remove them? He probably will. Nope, he does not. Oh, okay, that's good because I consider this to be a bit more readable. Okay, so this should actually take care of it. Hopefully, if my logic is correct, then you will now be able to see that if I make a line and I do a continuation, it will say it's okay. Every other direction is okay. And if I go back on myself, then it will not allow it. And then actually I should. You can see that in here it says 0, 0, 0, 0. Everything is 0. Here also everything is 0. In here, the first one is not even 0. The second one is not 0. It works. Okay, what if I do in a different direction? Because now I've always done a diagonal. What if I do a horizontal one, for instance, or a diagonal in a different direction? If I do this, allowed, 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 not allowed, 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 allowed. Perfect. See, this does not work. Perfect. Not considered to be a valid shape. Okay, the only thing we still have is indeed I cannot close the shape because it's considered to be crossing. But everything else is just working fine. Okay. Okay, so this is exactly what I want. If start equals then okay, then this is fine. I'm not actually sure if I really need this check, the O1 check. Because we're checking directionally. Well, I think we do need it because here is just to check whether one of the two is wrong. If I would only do this x direction is not the same as line direction, or y direction is the same as line y direction, then we would have problems. I'm not sure if the n would be fine. If one of the two, I think I can do n. And then I actually might be able to get rid of this check as well. And then I don't have to do all of this expensive checks, and I might just do a quicker check. Not 100% sure though whether that will work. This is something typically you would do with unit tests first. So that's okay, 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 okay. So that's, yeah, no, see, that's not okay. And this now actually is considered to be wrong. So there is definitely something, and that's because in this case it is saying -1, 0, 0, -1. So in the first step, look at my x direction of the line. So you have the line from here to here, and I go in the opposite direction, and that's why it's saying like, no, you can't do that because you're going in the opposite direction. Well, I mean, yes, I'm going in the opposite direction, but I'm not laying on the same line. So that's why I definitely need this. That's also why the end is not going to be strict enough, because here I'm saying it has to go both in opposite directions, which is not the case. One is enough, because again, for instance, this horizontal line, this is not being detected anymore. Yeah. So I do kind of need this. There might be other cases or other ways to actually make this a bit better. What do you say here? O1, why does O1 have to be different from, if O1 is different from 0, then we always say false. Why is that? Because if O1 is different from 0, that means if O1 is not 0, then the lines, then the segments are not on the same line, period. If O1 is not 0, then the segments are not on the same line. If they're not on the same line, they're allowed. And here I have the same as well. If and, well, actually I don't have to check line start, I just have to check. If I say crosses other lines, actually I don't even have to check crosses other lines in that point. Where is it being called? You say is the valid point, and I say is the valid line, and does not cross other lines. At logic for crossing, I assume that I don't need this part, but I mean, like, is a valid point. If I say points dot, wait, points, how do I get my first point? It's been a while, C sharpish thingy. Points dot first. If end equals point first, return true. Closing the shape is always a valid point. Well, no. So this is not working. Well, no. Not if. This is the first point. Well, no. Not if there. Not if there is no other segment yet. I mean, these are just checks that I want to put in there to make sure that, like, I don't have to check. Well, the valid line is a logic for crossing. That's what we did, but we did in a separate thing. So this is checking for, what is this checking again? Is valid line delta x minus 7 delta y minus 7 delta x equals 0 or delta y equals 0, return false. So this is just to see whether your line is an actual line. Because if this becomes 0 and this becomes 0, then okay, you have 1 point. Okay, yeah. Return delta x equals 0 or delta y equals 0 or math apps. Okay, this is to see whether it's okay. I get the point. What I'm doing here is to see whether I don't do something like this, but it's a diagonal line or a horizontal line. That's why. And then of course, if both of them are 0, yeah, then it's also not valid, because then I just have a point. So why is this here? Why is this wrong? Well, because if I do this and I do this, then now it would be considered to be a valid point. Very interesting. That then also fucks up my highlighting. Interesting? Really? Or did I mess something up in here? I thought I already fixed this again. I think it is because indeed it's because I definitely did that check. So I mean, like, that's the thing. Yeah? I mean, like, you can't say like, okay, if the end point is the same as your first point, then it's allowed, because it's not. Yeah, and then of course the highlighting is also problematic. Actually, that's always going to be a problem with the highlighting. Uh, hmm. Okay, so that's what I'm saying. Like, well, it's not if it's stingy. That's why I have to say if points dot count is more than one, and n. Why is that important? That points more than one, because you're not allowed to draw just a line and go back on yourself. You have to make a decent shape. That is currently just a restriction I put in the game. You can always change that later. The problem now is like you would think everything is going to work, but I think the clear highlighting is actually going to mess with it. I do this, I do this. It's just like you can't go back. I have to be bigger than 2, not bigger than 1. It should be not another segment. Why is that? Because index at 0 should be used instead of enumerable extension at first. That's interesting. I will fix that at some point, Sonarlint. I'm not sure if you're 100% correct, but look into it. So, like, I mean, like, if you have 2 points, 1, 2, then you can't go back on it. You need at least 3 points. So that's why now it's saying, okay, this is not correct. If I can go here, then now you say like, oh, this is a valid line, but it will clear the highlighting. So this is not valid because I go above it. But now it's a bit weird that the highlighting of this is gone because it removes the highlighting up of this section. So I don't think I can actually fix this. So even though I say this is impossible, I'm actually going to leave it in there because I still have to test out the special cases a bit. This I can remove, and I probably could put it more down here, so then I can see the special cases in action. Orientation is good. The clear highlight is another problem. I have highlight. I have the clear highlight of the cell, and I have the clear highlight of the line. I think this is what I'm using. If hover position has value and is valid point, then I say clear line, clear highlight, yes. I say clear highlight point is at last and hover position value. Yeah, so it's basically checking whether this was a valid point. And well, it was a valid point. I think that's also where did I add my check in there? Yes. So I say like, well, this was a valid point. So you have to clear the highlighting. The problem, of course, is that clear highlight, say vector start end. I should not get line positions. Those are all the positions from the line from start end. That's a vector 3 int. That's a square. Then I think what I also should do is I have to say like don't clear the starting point if positions my equals points dot so this I think should fix my problem. It's a bit weird that this is being done, but there's no other way to, at least no other way that I can think of to easily fix it. So, because it's weird that you say clear highlight from start to end, and then it actually doesn't really clear the highlight from start to end. Okay, so this is nice. Nice. So now we are at the point where we can actually completely make a whole shape. I still have completed shape. Oh yeah, here I have the yeah, all of those things. I don't see any special cases being locked anywhere. Interesting. That's because I didn't try to do anything special with lines, for instance, like this, and then actually very interesting. It doesn't. Okay, that's because it's only one line. If I go to the next one, then here, the special case 2. So it definitely needs special case 2, so I can't go down on myself. I can do this and this, and then again special case 2. If I go here, then that's crossing 1. If I go here again, then that's again special case 2. Oh, I still, oh, I did what? Oh, yeah. Okay, my check on is a valid point should not happen here. So I was hoping to be smart, but apparently I was not smart, because of course I first have to check whether it's a valid line. Yes, indeed, because my current check would actually destroy everything. For instance, I'm saying like, well, I can do this, and I can do this, and I can do this, and then all of a sudden this becomes a valid line. Excuse me? No. Okay, so we first have to check, of course, whether it's a valid line. That's important. Check whether it's a valid line or not. It has to be a valid line, of course, and it should not cross any other lines. But then here, I should do, if your end is the first point and you already have a first point, then false, it does not cross any other line. Well, actually, it can still cross other lines, so this is not even correct. So this is indeed not what I want. So what do I want? I want to say, okay, crosses other lines. If start equals line end, I should say if end equals points first position. Let's see, if we say for index of counts -1 for all points actually I should just continue this, no? If I say if end equals maybe should do if let's move this up here, because here I'm comparing it with all the points, all the segments. But what I should do is if I say if my points dot count is larger than 2 and my end equals my first point, then I should say int start index equals 0, and then I should say start index equals 1. So why is that important? This is to avoid the whole section, and I think this is the only way you can really do it properly. Maybe there are other ways to do it as well, but this is just saying, okay, just skip the first points to check for crossings and just go to the next one. Why? Because of course I still want to check for crossings with other points. So this is not a valid line. That's okay. That's perfect. If I go here, then this is a valid shape. Okay. If I do the exact same, but I go from here to here, I go to here, and then I go there, this would not be valid. If I go to here, then again it says like just ignore this first point and just check for crossings with the other ones. And I say, well, you overlap with it, so it's not allowed. If I then go up here and here, then this becomes allowed again, and that's a shape. Okay. So I think this is now working kind of good enough, and that's what I have to do. I also noticed that indeed my highlighting clearing Still works. It doesn't clear the highlight of the end point or the first point. Okay. And then for the special cases, I think we should probably also try to indeed like go from different directions. Special case 2. Um, special case 1. What was special case 3 and 4? That means, yeah, as I said, I don't think you can actually have these two because I always only manipulate start and end. So yeah, but I'm gonna leave them in there just in case. You never know what they're actually still doing or what they're good for. But I think special case 1 and 2 actually are enough. And that's what I said as well. Like I don't see why you would have to check these two. Because I mean, like, if you know that the line start is between start and end, and if you know line end or line end is between start and end, then that should actually be enough to know. The only thing I'm not so certain about is like the O values, which I'm not sure if you need that start end line end, and the line start line end start, and those kind of things. I think that's really more for very generic cases. Um, where the directionality is also very important, or like where you have lines and you don't really know where start end and those kind of things is, but don't think I need them, but they don't seem to impact performance, so I'm just going to leave them in there. uh, I will remove all the special cases, the debugging, and so this is something typically you would do with tests, and like you have to make sure you have tests for it. And I think I should at some point really start adding tests for all of this code and maybe clean it up a bit because it's getting a bit long. 300 lines. I typically try to keep my lines I keep all my logic at 200 lines at most, and we're not even there yet. So very interesting. Everything very interesting. It needs to be cleaned up. It needs to be reorganized maybe a bit. But for now, um, this seems to be working fine, and it seems to be okay enough. This method only works in okay. Yeah. Why is this is it going out code? No, it's this method only works. That's not going out code. Ay, 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 ay. Here. Not code anymore. Okay, still complaining about this. Whatever. Don't understand why he's complaining. Maybe it was the semicolon. Oh my god, that's a very stupid way to detect whether something is code or not. Just semicolon. Yes, the out of bounds check is something I still have to add because this is just ridiculous. And actually, that's very easy to check as well, huh? Because you can say is valid tal position. If not is valid tal position and return false. Which actually makes me think, like, should that not be done if is valid point cell plus if has value is valid? Okay, that's being called in many places already. It's for the clearing highlight and stuff and highlighting previous one. So yeah, okay. So no. But I think by adding this small check, it should actually be good to go. The out of bounds check. If I now make a point, wait, if I add a point, okay, I have to add a new point. See, this one is valid, this one is not valid, this one is valid, this one is not valid. So that's all perfectly fine now. I also make a bit of a more bigger shape. Yes. None of this is allowed. Well, this is not allowed. Sideways, yeah. So just adding that simple check was enough because I already had the logic. So next, of course, would be that if you complete a shape, you actually remove all the highlight, complete shape. To do color the shape, to do remove highlight, remove highlighting, or just remove highlight. That's good. So those are things you still have to do. I have to say, okay, completed the shape. If you complete the shape, you have to color actual the shape with the actual color, and you remove the highlight. Easy peasy. Coloring the shape is of course going to be interesting, and that's the next thing. And I was already looking up some algorithms about it, and those algorithms seem to be, well, I haven't found a very performant algorithm, but I hope I can get it to work sufficiently well. So okay, that's it for today. I'm definitely going to commit this because I've noticed that I have not been committing very well. What did I actually do? Attempted better crossing algorithm. Okay, nice. Yeah. Implement working crossing algorithm. Hits status. What else have changed? Nothing. Hits push. I'm on the master branch. Interesting how my Git still creates a master branch, not a main branch. I'm not sure if Git actually has changed the default from master to main. But anyway, I'm sidetracking. So okay, so that's it. Everything works. That's the next another step. And so next session, which unfortunately is not going to be next week, but will be a week after, we are actually going to look into the algorithm to fill the shape. And as I said, I have looked into it a bit, and the outline will be something like so private void fill shape will basically be like, okay, determine min and max x and y for all points in, not in the shape, in the boundary. See if they are in the shape. Simple. How do we see within the shape? How do we know if they are in the shape? It's like cast a ray from the point and count how many segments we cross. So that's basically the only algorithm I could really find that, well, so far at least I was able to do it. Another thing, of course, I'm thinking of doing is actually checking in Unity itself if there is something to make shapes. Could I, for instance, make a shape in Unity and then just say, okay, this shape and now fill it? I don't know if that's there, but it could be. It could be I can just create a shape with these edges, and then I can just say now fill it, and then I basically delay, or I push the problem of finding out which points are in the shape to Unity. But anyway, so this is the algorithm I found. It's like you have to basically, if you have a shape, you take a point and you cast like a ray in any direction, and you count how many edges you cross, and that's where the whole convex, concave shapes come in. With a concave shape, it's actually very easy because you should only always cross one. That's it. And yeah, that's basically it. With a convex shape, which is what I allow, you can actually cross one and then you can cross again another one. I might actually do some optimization about the algorithm as well. Instead of just always having to calculate everything in once, I might just do lines and columns and just count how many segments actually there are on there, which could be a bit tricky with like lines on the segment itself. Because then it could be like, oh, this is inside of it, it's not inside of it, inside, not inside, not inside, inside, not inside. So I have to see how that goes. Because of course the points on the boundaries will be tricky. Then again, maybe I don't really have to. Maybe I have to not include the boundaries and do the boundaries separately. So those are all things I'm gonna look into next time. But as I said, I hope I can actually find would be better if Unity can do this for us. But then indeed I have to look at some kind of shape in Unity, which I'm not sure if they actually have something like that. You have a shape control point, you have a shape module. Shape control points, yeah. But I see light shapes, which is not really the type of shapes we need because that's for lighting. Shape control points. Yeah. Unity to do shape control points. Sprite Atlas, Sprite Bone. Doesn't really seem to be exactly what I want. What else? Yeah, the shape module. That's the whole module. What's inside of the shape module? Where am I even looking at? Yeah, okay, I see it here. Shape module. I think particle system. It's also not gonna really do a lot. The sprite shape renderer. I'm seeing people suggest. So that's something definitely to look into. What is the sprite shape renderer? Sprite shape renderer renders sprite shapes. Defined through the sprite shape utility generate sprite shape. Sprite shape utility. Generate a mesh based on input parameters. You have generate and you have generate sprite shape. Okay, why do you have two? Okay, that's really with the mesh and stuff. Using sprite shape renderer. Oh my god. Sprite shape parameters, shape control point, sprite shape metadata. That's a lot of information that you need to pass on, which I don't really have. Render sprite shapes defined through the sprite shape and sprite. Yeah. Here they're the same thing. My approach would be to fill the shape with a mesh to draw the material. Okay, but this is not even Unity that they're referring to. Why is somebody on the Unity forum like linking to a whole different library and stuff? Creating a mesh with a polygon shape tool. But I don't really want. Okay, Unity create shape and fill it from script. Okay, that's yeah, sprite shape seems to be something they are suggesting. Sprite shapes. So I definitely have to look into the sprite shapes, I guess. I don't really, yeah. Sprite shape. Sprite shape segments, sprite shape renderer, sprite shape parameters, sprite shape utility. Yeah, okay, then I have to look into how to actually use sprite shapes then. Yeah, shape renderer. There are people here who, oh, they do it. Okay, but that's a whole different. The shape renderer is a whole library, a whole package. So maybe not the best thing because it's pretty big. Okay, so people are indeed saying shape. Oh, shall of course that sprite shapes. That's what seems to be. They've been built into Unity for a year or so, and that was 5 years and 6 months ago. The post was at 2019. The original one was at also 2019. Okay, February 23, 2019. So in the meantime, we're 5 years later, so they should definitely be in there. Okay, so I have to look into how to do the sprite shapes. So yeah, that's all for next week. It's going to be an interesting way of doing it. Okay, look into sprite shape. Okay, that's all for that I have for today. See you next time. Bye.